welcome everyone. We are just getting everything set up and ready to go here. Welcome Amol. Welcome Eli. We are getting everything ready and we're ready to go. We got a busy night ahead of us that's planned. We're going to be getting quite a few objects tonight, so we're going to be fast, we're going to be furious in the beginning. We got to plan just right, where things are going to be coming up just at the right time. First object that we're going to be getting is a small object. But again, it's one object that I have never gotten before. Joanne, welcome. Yes, you are here on time, which is fantastic. But the object that we're going to start off with tonight is NGC, which is New General Catalog, 6826. That is the object that we're going to be getting tonight. It's a small object, very, very, very small. Its apparent size is 2.1 arc minutes, which means that is the size, just about the size of a star. So that one is tiny. We're just waiting for the guider to finish. It is just about done, and we're guiding. Okay, so let's flip over to the long exposure. Now, if you don't know what NGC 6826 is, well, it's what's called the Blinking Planetary Nebula. It's a very small one. On the camera on the left, you're noticing that you see right there. And again, this is a very short exposure. It is not 480 seconds. This is actually 12 seconds. 12 seconds, and the gain is 20. So we crank the gain all the way to max on the camera on the left. And that right there, and I'll put the mouse right on it, this right here is the Blinking Planetary Nebula. Kind of crazy, huh? I know. Now, this is zoomed in at 200%. Now you're probably wondering, you're probably like, seriously? Like, how do I know that that's the Blinking Planetary Nebula? I mean, seriously, like, that could be anything, really? Well, based on the star chart, and based on where it is, I could zoom this out here to, like, say, 75%, alright? And I can even go a little bit less than that, so say 50%, okay? Yeah, it looks like a star, but if you're looking at the star patterns around that, I'll go to 33, you're noticing that there's two little stars right there. Now, I could pull it up on my carte de ciel. I know it sounds so weird. Carte de ciel. Okay? Those two stars are these two ones right here. If that makes any sense. Because you have it right in view. Does that make any sense? Well, actually, I think hang on, let's get that. Alright, there it is. Okay, NGC 6826 is right there. There we go. Now you'll be able to see it. We'll zoom it out. Okay. Now, the camera on the right, we're just going to take a quick exposure here. We'll take a 30-second exposure. And we still have the hydrogen alpha filter on. I have not changed it off yet, only because we're going to be getting some hydrogen alpha objects later on tonight. Gonna need the color on this one, please. Yeah, you're gonna need the color. So we're gonna do color I could flip the filter if you want. I'm gonna have to refocus it. Next time I want to capture with the ZWO120 MCS. Yes, definitely. You guys... And welcome, Genghis Khan. And Chris, you said that you've captured this before. We are going to change the histogram on the camera on the right. There we go. Just getting it centered here. There's the 2 stars there. I just got to get it centered between the 2 of them, so give me 1 second here. We want to get this just right. Alright, so there's the 2 stars. To the left. This is it right here. Alright, I found it. Trying to get it centered with the other camera here. Okay, there we go. I know where it is. They're not oriented correctly, so that's part of the problem when I'm running into, is that they're not oriented. More towards the center. Okay, there it is. I was looking at the bottom. There it is. Alright, let me get it centered. Alright, that's the blinking planetary nebula right there. So it's on the camera on the right and now also on the camera on the left. So let's... There we go. So now it's on both cameras now. So now you'll see it. I was looking at the wrong thing. Alright. Looked like a green-blue... Exactly. It's like greenish-bluish. The only reason it's red for mine is because it's a hydrogen alpha filter. That's the only reason why it's like that. I could flip the filter, but I'd have to refocus. I don't have the motorized filter wheel yet, so that's part of the reason why. But what I could do is I could take down the gain. Well, I'll take down the exposure time here. I'll go down to 7 seconds here on the camera on the left. So what it'll do is it'll look like actually like fuzzy. There you go. So now it's starting to look a little fuzzy. And now what I'll do is I'll go to 400% here. There we go. And then what we'll do is we'll go down to 5 seconds. So you'll actually see this. Alright, so this is a 5-second exposure. How about that? So that's your 5-second exposure of the blinking planetary nebula. Alright, and then we're going to set it up for this one here. As we're just going to take just 30-second exposures here. There we go. So now it's going to take images there. Oh yeah, DSLR. Yeah, it's got a gigantic lens. These ones are actually pretty good lenses too. They're pretty darn big. The camera on the left has a sensor. Now, what it has is it's the reading size, which is 4640 by 3506. The other one is just a little bit smaller. I think it's like 4535 by 3430. So they're pretty darn close, and they're just about the same as what a DSLR is, which is called. And then if you know what DSLR is, it's a digital single lens reflexor, DSLR. So it's a digital camera, is what it's called. So by the way, these are live images. If you're just joining me and you're just wanting to know how this is all working, and we do live, you know, as live can be. So this is a 30-second image on the right, and in just a 12-second image, or actually no, it's a 5-second image on the left. And you could see, I mean, how cool this is. Now what I could do is I could change the histogram just a little bit so I can bring out some of the detail, but I don't want to knock off too much of it. There you go. But you can really see that blinking planetary nebula, which is so cool. You have a center core of it, and then you have just the outlying area after that, which is really neat. Now, am I going to be able to get super detail like what the Hubble gets, or, you know, a 10-inch or 12-inch scope? No. But looking at this, it's really neat. And what I will do is I'm going to start taking a sequence here of this, so this way we can stack it. Alright, so hang on. So here's what I'm going to do. We're going to go to 20%. Okay. Alright, so now we're going to take just a sequence on the left. So this way we'll be able to stack them one on top of the other. We're going to just do 10-second exposures at 20 gain. Okay, so we'll do 20%. 20%. There we go. It's pretty cool doing live view with the astronomy camera. Then DSLR. The exposure was amazing with the ZWO camera, and the object was up close. Then, yeah, that's the thing. The ZWO camera, it will have a smaller sensor. So what that means is with it being a smaller sensor, you're going to get more magnified view. Two cameras here are about the same, which is great. So your field of view is going to be just almost the same, which is great. And the compensation for the right camera versus the left is the right camera has what's called a focal reducer, which reduces it down from 545 to 454. That's focal length. What focal length is it's the distance between the front mirror or the front glass to the sensor. That's the distance. And the focal reducer reduces that time, which means you get a faster image. The one on the left has a focal length of 360, but it's 61 millimeters is the aperture. That's the aperture, that is the diameter of the actual scope itself. So 61 is the left, 80 is the right. And how to figure out what's called F ratio is you take your focal length and divide that by your aperture. And that's what your F ratio is. The closer to 1, the faster your images will be, which means you'll be able to get more light faster. So the scope on the right was like an F5, but by getting the focal reducer, brings it down to an F4, which means you get better images faster. The images on the left are an F6, because you take, well, now it's about an F5-ish. It's like 5.2. So they're roughly about the same. So it's 360 divided by 8, by 360. Yeah, so it's 6 divided by 61. So it's 6. So it's a little bit slower, which is fine, but it's a monochrome camera, which means that speeds it up. So it's kind of confusing. Exactly. The problem, and Chris, the thing is, when you're looking at a DSLR versus a CCD camera, which again, CCD is cooled coupling device. Cooled coupling means that it's a cooled camera, which means you could set the temperature and keep the temperature all the way through. So with a DSLR, there is no like cooled, it's not cooled. So nights like this, when it's 85, 87 outside, Fahrenheit that is, you have to add at least 15 to 20 degrees above ambient temperature. So that means if you're running a DSLR, the camera's sensor is about 120 degrees, 115. The more heat that is on the sensor, the more noise is caused in the image, if that makes any sense. But when you have a CCD camera, it is cooled, and now it's a chamber. And some cameras have argon gas inside of it, which keeps it crisp. And you can get temperatures as low as -40 Celsius, which is crazy to even think about. You can actually image, and the temperature is 40 below zero in Celsius. That's just crazy. So we are taking one image after another after another. Again, these are just 10-second images on the left. I'm going to change that because it was 12, but now we're back down to 10. And again, we're saving all these images. So this is not just a live image and then they're gone forever. We're saving these, which is what I want, which is phenomenal. As Amol says, F yeah. which is awesome. This is like a warm-up to what we're going to be getting later tonight. We got some great objects coming up. Objects that I haven't gotten in 5 and 6 years. So, it's going to be interesting. There's also going to be a lot of unknown tonight, too. So, I don't know how they're going to turn out. This is one of those trial and error things. I really don't know if it's going to be good or not. I have it planned. So we'll see. Somebody was just talking about an Altair CCD camera. I forgot who it was. On my channel, they were just talking about an Altair, saying it was a great CCD camera. I forgot who it was. I don't know if it was Gary or James. Somebody was. Or it might have been Astro-Imager. One of them was. Alright, so we've taken about 37 of these so far. We'll take about 40. And we'll be in good shape with that, because 40 will be good. At 10 seconds. You don't have to take super long exposures with these, because it's... Yeah, it was Astro-Imager. That's what I thought. That's what I thought. Which I hope he comes on later tonight. I hope he does. Alright, so now we'll stop it because we've taken 40 images at 10 seconds. Now we'll up the exposure just a little bit here. To 2 minutes. Alright, so we'll go to 2 minutes on this one. Oh, there was a satellite that just went through too. How cool is that? That's awesome. So now we're taking 2-minute images. Yeah, Altair is a great camera. I like the ZWO series. Yes, so Amol, what they are is, for the CCD chip, is they're better. In my opinion, I would rather have a CCD chip. I mean, you could technically have the chip from a DSLR and put that in as a CCD camera. The big difference between a CCD and a DSLR is that it's cooled. Like I said, it makes it a more crisp image, and it makes it a lot easier, and I'm sure Chris can attest to this, Astro Live, is that it makes it easier to take calibrated frames or calibration frames, lights, flats, darks, biases, because you know the temperature, and you can set the same temperature for the flats along with the lights, because we're taking light frames now. That's the data that we're taking. But the problem is with a DSLR, you could take an image today at 85 degrees outside and come back next week and want to take the same image, but it could be 64 degrees outside. And it's going to mess it up big time. That's the difference. That's the problem. And so the first 2-minute image is done. So you can see the star field, which is nice. So again, this is just a intro to what's to come for tonight, because we got some great objects coming up. Because we are about, let's see, looking on for time. About 20 minutes, and we're gonna move to the next object. We're gonna increase the exposure just a little bit more, because we'll be able to stack these, which is nice. Alright, so we're going to increase the exposure on the camera on the right. To 2 minutes also. Then this way we'll get brighter stars. And Joanne, to do this in color on the camera on the left would be kind of hard. And then flipping the filter, I'd have to refocus this all back together again on the camera on the right. The only difference is with this is if I were to flip this, it'd just be blue. Really, that's all it is for this one. I mean, the biggest goal that I wanted to see was, can we see the outside layer of that nebula? And we did. That was my biggest goal, and we nailed it. We nailed it dead on, which I'm very, very happy about. Yeah, they are. And that's exactly right, Chris. They are all going to CMOS sensors, but they're sensitive enough. I mean, you can modify a DSLR camera and you could pick up, you know, H-alpha gas easily. Which is ultimately what you would really want anyways. Alright, so this is the 2-minute image at a 6 gain. But you can see how bright this damn thing is right there. That is the blinking planetary nebula right there. So the camera on the left, you're seeing this big white ball. That's it right there. So we had a low exposure of 10 seconds, and then now we're just, you know, stretching the histogram and doing everything we can so this way you could see what this looks like. So you get an idea. Yeah, where is Kim Twister? That's a good question, Amol. That is a good question. Let me message her and let her know that we are live, because we got 6 people watching right now. We're having a great time right now because we are getting a small object. It did. It did. Because these satellites are just all over the damn place today. I'm actually going to check and see. Yeah, you guys are right. So in about 10 minutes, we are going to be flipping to the next object. We have 3 objects after this to get. One of them we've already gotten before, but I want to try to add a little bit more to it for data. The next 2 after that, we've never gotten. So it'll be fun to get. So I'm super, super, super ecstatic for this next one. So, and by the way, if you're just joining me for the very first time, as I know there's a lot of people that have come on, been spreading the channel around, which is awesome. We go, and it's a great community, and we get objects, and drop a comment, say hi. That's what it's all about. We get long exposure photography. We like to have process parties, which is great. And it's just a good time to just listen to music and just have a relaxing time. Because we've all had stressful days. We've all had days where you're stressed out, you need to unwind. Why not look at the stars? Why not have a good time? Why not I bring it to you guys? That's the most important thing. Is I'm going to be on for the next 3 to 4 hours. And here's the best part. Come on for a few minutes, say hi. Say, let's go get this object. Have a drink. Get something to eat. Watch a movie. Come back. I've actually had people do that. They'll come on, they'll say hi. And then they'll leave for 2 or 3 hours and then come back and go, good God, you're still on? I just love it. It just, to me, it doesn't get old. And to me, it never will. There it is, right there. So even at 2 minutes, you could still see that it's an actual, like, planetary nebula, which is crazy. Why do you think I'm here every night? Exactly, Joanne. Exactly. And especially when we had that wonderful, I don't know, what was it called? Quarantine? I streamed, 13, 14 straight nights of 2+ or 2.5 hours every single night. I mean, hell, right now, with tonight, this is 9 out of 10. So we streamed 7 in a row. We took a night off. We were out last night for about 2.5 hours. And now tonight we'll be out here again for 3+ hours. And we got 4 objects lined up. So we got 4 minutes and we're flipping the telescope to the next object. The reason why, like I said, I have a time limit on all of these is because they have to hit a certain altitude. so this way I can see and start imaging them. So the blinking planetaria, and here, we're going to do a table of contents. The cat's out of the bag. You want cat's out of the bag. Ready? These are the 4 objects, technically 5, because I'd like to see if I can get 2 objects into 1. But these are the 4 objects, so get your mindset. Get ready, because here we go. Blinking planetary nebula started at 10 o'clock. We're going to go till a little after 11, about 11 p.m. We're going to flip back to the elephant trunk nebula. Like to get that again. We're only going to spend about 40 minutes on that ish. So and this is good, so this way if you want to see a certain object, come back at that time. Elephant trunk nebula is going to be about 11:15 to midnight. Okay. Then at about 12:10, so it's going to take me about 5 minutes to get this next object. At about 12:05, 12:10 a.m. Eastern Standard Time, we're going to be getting the cave nebula. Ooh, the cave. We'll work on that one for about an hour. That'll take us till about 1 a.m. And then after that, we're going to go to NGC 7822 and a special guest of Cedarblad 214. We're going to work on that for about an hour. That'll take us till 2 a.m. So, 4 objects. Technically 5. We're going to have fun. Again, this is just a little blinking, and it doesn't really... It's not really... I'm not going to see it blink. Well, how about this? Let's have a little story time. Because on every stream, we love to do story time. So here we go. NGC 6826, grab your drink, grab your book, because here we go. NGC 6826 is a planetary nebula located in the constellation of Cygnus. It is commonly referred to as the blinking planetary. Although many other nebulae can exhibit such blinking, this bright 25 arcsecond diameter planetary nebula lies southwest of an 8.5 magnitude star. Stare at the planetary's magnitude 10.6 central star through a medium or high power eyepiece until its brightness overwhelms the eye and causes the nebula to fade. When you then glance away and look at the nearby magnitude 8.5 star, the planetary's disk will reappear. NGC 6826 has an apparent diameter of 2.3 arc minutes and a photographic magnitude of approximately 10. That just means is that when you photograph it, it appears bigger than what it really is. When you're looking at it through an eyepiece, you need a high power magnification eyepiece. This alteration between direct and averted vision of the planetary's nucleus thus causes the nebula to blink. Many planetaries with a prominent central star will produce this phenomenon. The different combinations of central star and disk brightness in other planetary nebula will require different magnifications to produce the blinking effect. A distinctive feature of this nebula are the 2 bright patches on each side. Now, we won't be able to see that because of the way that my telescope is, with it being a 60 millimeter and an 80. You won't see it because you need to have it as a 10-inch. So, if you have a 10-inch scope or an 8-inch scope, go for it. I'd love to see it. So it has 2 patches on each end, which are known as FLIER, which is called, get ready, the Fast Low Ionization Emission Regions. It's an acronym. They appear to be relatively young and moving outwards at supersonic speeds. Yes, it's going to be a busy night tonight, and I'm so excited. I can't wait. because guess what? It's 11 o'clock. We're moving. We're gonna move to the next object, which is so awesome. So we got quite a bit of these objects, of these images of the blinking planetary nebula. We took about 55, so we're gonna do a batch save here. So it's going to save each one individually. Alright, so while it's doing that, we are going to move the mount. Or technically move the telescope, but you know what I mean. So we're going to stop the guider. We're just going to wait for it to save real quick here. So it's saving 53 images right now. Alright. Just because we took those 10-second images, we took so many of them, it's just saving it. Alright, saved them all. And then what we'll do is we'll close them all out. So we don't get them confused with the other ones. We save them all. Perfect. There we go. And now we get to move the telescope. Yay! Move the telescope. Alright, so we're going to move it to the Elephant Trunk Nebula. So get ready, everyone. Alright, there we go. Alright. So again, if you're just starting to watch this channel, I'm going to show everyone how this works, which is really cool. And this is what's called the plate solving. And Chris, you can attest to it. Joanne, you've seen it many times. Amol, you've seen it lots of times. It is a great way to find out where certain objects are in the sky without having to pull your hair out to try to figure out, okay, are we here? Are we there? I can't find the object. I mean, we were finding objects that were 16th, 17th, and even 18th magnitude for galaxies. In other words, that's tiny. Like, beyond, like, small for, like, a star. And we were getting it, like, with ease. Finding it, like, in 5 minutes. Now, is my plate-solving skills perfect? No. Nowhere near that. But I can get it, and it's really quick. Alright, so now we're going to save it. And we're going to find out where we are in the sky. Usually it takes me one plate solve to figure out where we are in the sky, then I move the mount, and then we go. Alright, so now it's going to try to find it. So on the bottom left, you see the little reticle, the little bullseye there. Not the one, not the mouse, but there's like a little bullseye that is right on top of the Elephant Trunk Nebula. Now, what it's doing is I took a picture of where it, in quotation marks, where it thinks it is in the sky. Once I take the picture, then it will actually sync with the mount and actually move that reticle. Then I just move it to where it is, and then we'll be dead center. So majority of the time is it trying to find it. The better the picture, the shorter the time for it to find it. Usually, yep, I was about to say, usually takes about 40 to 50 seconds, and then it finds it. So it found it. So now it's going to synchronize it, and it's actually not too far, so that's perfect. So now we're just going to move it over to the right. Perfect. Right there. So now we're just going to wait 10 seconds. So now you saw on the bottom left, you saw it drift. You saw how it moved over to the right, and then I just shoved that back over to the left. So now it'll be exactly right on top of the Elephant Trunk Nebula, so we won't have to worry about it at all. Which is quite incredible if you ask me. I mean, you could even time me of how long it takes. It doesn't take long. Alright, so now we're just taking a quick 13-second exposure. See where we are. Perfect. We're right on top of it. That's exactly where it is. So now, if I were to just do this 13-second exposure, I can adjust the curves. Yep. We're right where we need to be. Fantastic. Alright, and then we should be dead center too. Let me check the other camera. Fit to window. Preview. Take a quick 10-second exposure. Perfect. Alright. Now let's pull up the guider. And there we go. Perfect. So now I just updated everything on there. So again, what we're doing is we're taking an 8-minute exposure on the left and a 10-minute exposure on the right. So this way we'll see what they look like on both. And again, we'll get about 3 or 4 of these, and then we will flip it to the next object, which is the Cave Nebula. That'll be the next one, which will be super awesome. Oh, and by the way, also, just to let everybody know, I did order the hydrogen alpha filter for the Meade camera, which is nice. So we'll be able to get hydrogen alpha in both cameras. Big thanks out to Saboni, which is how you spell it, is S-V-B-O-N-Y. Big thanks out to them, as we are going to be using that, and I'll be writing a review on that and then also testing it out for the hydrogen alpha filter. It's a 7 nanometer hydrogen alpha filter. While we're waiting for the images, let's talk a little bit about the light spectrum. Now, I'm sure, Chris, you know about it. You deal with this astrophotography and astronomy. Hell, it's in your actual name, Astro Live channel, so you should know. But I'm going to go over it real quick, okay? So what that means is, it's what's called the light spectrum. Alright, so I'm just going to go briefly in this. There are different gases that are out there that you would need for filters, okay? The one that we use, and it's called wavelengths, okay? That's usually what you would call it. And it goes by, the lowest is in the high 300s, and the highest is in the upper 7s, which is called nanometers, okay? If you ever get a chance, make sure you definitely check out the light spectrum, because it is really, really cool. And it gets pretty detailed, too. Now, there are different filters, like I said. One of them is hydrogen alpha, and that's what we use to get hydrogen alpha gases. There are a lot of hydrogen emission gases that are out there that are objects. Hence, the Cave Nebula, the Eagle, Lagoon. There's the Satyr Complex. There's the Crescent Nebula. There are so many that are in there. When you use the filter, it only emits that light to get through to the sensors. So what that does is it cuts out all the other light. Okay? And of course, naturally, there are different filters that cut out different ones. Now, if anybody has ever heard of what's called the Hubble palette, H-U-B-B-L-E, Hubble, like the Hubble telescope, there's a palette, okay? The Hubble palette is used by 3 filters that you would use. 1, hydrogen alpha. 2, oxygen 3, so yes, there's an oxygen 3 filter. And 3, sulfur 2. And those 3 filters combined, you get a phenomenal image, and we will be doing that later this summer. We will be getting all 3 filters and putting them together to get what's called the Hubble palette. Now, there are other filters out there, which is crazy to even think about. There's more than just those 2. You also have hydrogen beta. So technically you could use that one if you really wanted to. And I've used hydrogen beta before, and it's quite interesting to use hydrogen beta. There's helium-2. They're less known, but it's there. There's a helium-2 filter. Then there's also a nitrogen-2. which you could use. Now, the helium-2 sits between hydrogen beta and oxygen-3. It sits between the blue and the green. How the light spectrum works is that it goes from purple to green to yellow to orange to red. Hydrogen beta sits in the blue. Helium-2 sits in the teal. Oxygen-3 sits in the green. Hydrogen alpha sits in the red. The nitrogen-2 sits in like the dark red, but not totally dark red. And then sulfur-2 sits in the deep red. If that makes any sense. So, that's the wavelength in a nutshell. Exactly. And Chris, actually what you could do is there's also filters. There's nebula filters. There's IR cut filters. There's UV filters. There's so many different filters that you can use that will work. For the camera on the right, what the frig is teal? Well, teal, it's like blue-green, pretty much. It sits at about 500 on the light spectrum scale. 500 nanometers is pretty much what it sits at. How does this one look? Oh, that looks... Oh, that looks beautiful. Look at those stars. Wow. I could probably easily go 15 minutes for the way that guiding's going right now. Dang, that looks good. Yeah, so basically blue, yes. That is absolutely perfect. And then the elephant trunk sits right here. So I'm going to get this centered here. Right there. Hot dang. That is ridiculous. The detail you get on this. That's without a hydrogen filter. My God, that is ridiculous. And this is a 10-minute image coming up on the right. Now let's take a look at this one. Now it's going to be bright only because I was doing the other one. So let's see here. It's going to be this right here. Ah! You can just barely see it on the camera on the right, but the one on the left is just insane. That was a firework. That scared me. Yeah, so it's going to be right here. This is going to be where the elephant trunk sits right here. It's going to be going from left to right. We may have to take a longer exposure on the camera on the right, which I'm perfectly fine with if I have to. And we'll be adding this to what we've already taken in the past, so I'm very excited about that. Which I cannot wait for this hydrogen alpha filter to come in, because I'll be able to get a more crisper image. You'll be able to see more detail, and I'll be able to take a longer exposure. This is an 8-minute image on the left, and then a 10-minute image on the right. We may push this to 15 on the right just to see. I may just do 12. 2 minutes might make all the difference in the world on the camera on the right. Naturally, if you're looking at this, I mean, this is the elephant trunk right here, and it's going from south to north. It's pretty darn awesome. The stars look absolutely friggin' pinpoint. The guiding is just insane right now. Right, next image is now done on the camera on the left. And what I'll do is I'm going to adjust this without zooming it in. So we'll see the image as what it is, zoomed out. There you go. I did. I did message her. I got nothing back yet. Now we're going to do 10-minute exposures on the left. And then when this image is done, we're going to flip the time on this one to 720. So we're going to jump this and take it just a little bit further. There you go. There was a satellite that went through on the right side too. So as soon as this 10-minute image is done on the right, then what we're going to do is we're going to jump it 2 more minutes, and then we'll get a couple 12 minutes, and then we'll move over to the cave. That'll be the next object. Alright, so then we're going to stop it there. Okay. And then we move on to the next frame. Alright, so we're at 16% on the camera on the right. I mean, that's just a phenomenal image. I mean, that's just... And right now we're at just more than halfway on the camera on the left. So we are just flying through here. And the best part is, we still got 2 more to go. Two more objects to go. It's a Ron sighting. Welcome, Ron and Stacy. Welcome to the both of you guys. So we are getting, so you guys are just coming on in. We are getting the Elephant Trunk Nebula. I'm gonna pull it up for you guys here, which is actually gonna be right here on the camera on the left. This is an 8-minute exposure. What we're going to do is we're going to use the curves, and then what we'll do is we'll bring out the detail again. There you go. So you can see it in on the camera on the left. And again, we are taking it as an 8-minute exposure on the left and a 10-minute exposure on the right. We upped it. So now we're going to do 10 minutes on the left and 12 minutes on the right. Which is crazy to even think about that. And then what we'll be doing is, once we get 2 more of these, then we're going to flip it to the Cave Nebula. We'll get a few of those. And then we'll flip it to NGC 7822. And also Cedar Blade 214. I know, there's just numbers. So many numbers, so many names, so many catalogs. But I'll go over everything with you guys so you know exactly what's going on. But with the Elephant Trunk Nebula, it is, to me, it's a phenomenal. It's just a great object. Kind of looks like an elephant trunk in itself, and then I can outline it a little bit. And again, this is one single exposure, okay? So this would be the snout right here of the elephant trunk. Okay, by the way, you're looking at the camera on the left, and then it goes down, you know, north-south. So this would be the trunk, and then you can see all the little intricate detail all throughout here. All this is hydrogen gas all throughout here. So if I were to stack these one on top of the other, you are getting that rich hydrogen emission. Ron wants to know what 2 systems I am using. Well, the one on the left is I'm using what's called a system called Sky Capture, and it is a program that I use through my Meade camera. It's a Meade monochrome camera, so this is very sensitive, and it's through the luminance filter. So if I wanted to get something in color, hence like the Dumbbell Nebula, the Ring Nebula, the Fireworks Galaxy, Andromeda Galaxy, anything like that, I would have to shoot it through those 4 filters: luminance, red, green, blue. Next image is done. So we gotta get it closer to the center here. There we go. That's actually not too bad for a 10-minute exposure. That's pretty darn good. Hot dang, that's amazing. For 10 minutes? Whew! Alright, so and then the camera on the right, we are using what's called a hydrogen alpha filter on a colored camera. Yeah, that doesn't make sense. A lot of people look at that and go, why? Just why? Why would you do that? Well, because it works. You're not going to see much detail live, but when we stack it, that's going to be where the magic happens, because I'll extract the red channel out of it, and that's what you want. You want to extract the red channel, and you'll start getting detail. And when you stack that, then you're going to start seeing everything to come together into fruition. What I'm doing here is just getting this just right. There you go. Now you're really going to see the detail. But you can see how I'm taking a 2-minute less exposure on the left than the right, and yet I'm getting more detail, which is incredible. The stars look amazing for it being a 10-minute exposure, which I think we're now up to 2.5 hours on this object total, because we did get this on Wednesday, I think, of last week, or well, it's still this week, but technically it was just 4 days ago. But we did get this. We got about an hour of it before, and we're getting pretty close to another hour here. So we'll be able to, and that's the beauty of this, is we'll be able to use the previous session with this session and add it all together, which is incredible. I'm just looking at the stars on the camera on the right. Look pretty darn good to me. I think they look really darn good. I'm very impressed with that. Big question is what is the 12-minute exposure going to look like? That's the big question. What is the 12-minute exposure going to look like? Will there be star drift? Because we're going to take one more after this. We should be in good shape. It looks pretty epic on the stream. Probably could be a little bit darker. There we go. Thank you, Stacy. It does look amazing. I mean, just wait till you start seeing it come to fruition when we start stacking the stuff. It's just amazing. If you ever get a chance to look up the Elephant Nebula, Elephant Trunk Nebula, it's pretty amazing. And this is just a one single shot. Why does it make that shape? It's the gases in the... I mean, why does any of the stars make that kind of shape? It's kind of weird. Like, you know, the Crab Nebula, when the star blows up, it's a vacuum of space. So when it's a vacuum of space, that's what happens. And actually, the image on the right is done. And stars did not move much, if anything. They didn't move much. So yeah, it's going to be a little hard to see it on the camera on the right. Exactly, Stacy. Science. No one explains why these stars do what they do. It's just crazy. Star blows up, makes a pretty design. When it makes a pretty design, all those different colors are all the different gases out in space. It's crazy. Like, if I had to take this filter off on the camera on the right, you would see colors of the stars, but you wouldn't see any of the hydrogen emitted gas. If I put an oxygen 3 sensor on, completely different. If I put a sulfur 2, same thing. It's just different gases respond differently. Have you ever seen the auroras? You know, when you see the auroras, it's different gases, oxygen, nitrogen, helium, different gases respond differently. And Mr. James Dugan, how are you doing today? And happy Sunday to you. Even though it's 14 minutes and then it'll be Sunday. That's usually what I tell people eventually. It's just, how do things happen in space? Science. Crazy science. I'm going to zoom out on the camera on the right here. There we go. Oh, excuse me, I burped. The elephant trunk would be right here, but for some weird reason, we're just not getting much detail here. I mean, you could just barely see it, but it's kind of hard to see. Oh yeah, it's gonna be an awesome night, James. So far we did the blinking planetary nebula first. Had to wait for these other objects to get up high enough. We are about a couple more images away. Let me just change this back to 20% here. We're about a couple images away from moving the telescope again. Yeah, 0.7. I'm pretty ecstatic for this. I'm very, very ecstatic. Yeah, Chris, I did see that, and that's no problem. Yeah, I saw that you were streaming, and Ron's got clouds again. Oh, Ron. Ron with the clouds. The next object we're going to be getting is the Cave Nebula. Now, I don't know what's going to happen with this next object. I'm hoping we're going to get some detail, but I can't make any guarantees with the next object. What I can do is this. Let me go to... We're going to pull up one of the images here on nebulosity. I want to see and show everybody what we have. Especially for the camera on the right. Because the camera on the right, it may look like there's nothing there, but there is. Trust me. There is something there. And that's what I'm going to show everybody here. Okay, so we're going to pull this up here. Alright, so nebulosity is on the right-hand side, okay? By the way, the camera on the right. So you're looking on the right, you see what looks to be like a black screen. That's really not. Okay, so we're gonna stretch the histogram here. Okay. We're going to zoom in. Okay, so the elephant trunk should be right here. Okay, so you're going to see my mouse moving around there so you can see. Okay. And then what we're going to do is we're going to extract the red channel. Okay. And now it's becoming more prominent. Now you're going to start seeing some detail. Okay. Okay, so this is it right here. So you can see it just a little bit. Again, this is one shot. This was a 12-minute exposure on the camera on the right. Okay. Now I could zoom in, but the problem is it's going to become all granulated. So there's really not much you can really see when I zoom in like that. But it's going to be right here. So it's going from left to right. And then this is the little snout right here. This is the snout of the elephant trunk. And then it goes this way. And then it looks like it's like jig-jagged right there. So if that makes any sense. I figured I'd just show everybody that. And you can get an idea. So we're going to take one more image on the left, and then we will move to the cave, and we'll be right on time. Because right now, for time-wise, let's take a look and see where we stand. We are at 5 minutes out of 10, so in 5 minutes. That'll be perfect. Jig-jagged. I love to have fun, by the way. It's always so much fun to do this stuff. I like to be technical with some of the stuff, and I like to have fun. I mean, I have to say, at 10 minutes, this exposure is phenomenal. And it's, to me, it's absolutely crazy that you look at this image here on the camera on the left, and it looks like nothing's there. It just looks like just a regular image of just stars. And then you take the histogram and it's like it's a hidden image. It's unbelievable. Of course, naturally, the star field is gigantic. Because when you're looking at the whole image here, the elephant trunk sits right here. This little thing right here. And then all of this is all hydrogen emission all throughout here. Oh, excuse me. Now, it's not on here. I should have moved it down a little bit, but the garnet star is just out of view. So the garnet star yeah, we just missed the garnet star by just a little bit. It would be up at the top right. It would be right in here. So I should have moved it down just a little bit. But that's okay. So we are about 2.5 minutes away from getting our last image of the elephant trunk. Yeah, it does. So like what I could do is we could take this here, we can go back to here. We go 20% image, adjust, curve. Whoops. Everybody want white flashlight? Whoops. Doing this without a mouse is like atrocious. Who wants to donate me a mouse? What's crazy about this is, again, you're getting the black outlined circles is because I'm stretching the image so much. When I actually stack this the right way, it'll be a flat field all the way through. But the elephant trunk sits right in here, which is crazy. This is the elephant trunk right here. And it goes down this way, so that is just crazy. So we're going to have fun processing this one. Tons and tons and tons of fun processing this one. So we're about 4 minutes away. And then we'll move to the Cave Nebula. And this will be an object that will be a little bit of a challenge. But there's no challenge not too great for me. So this image is now done. Alright, so we're going to stop it here. So we've taken 1, 2, 3, 4, 5, 6. We've taken 6 images so far. So, that's done. Camera on the right has about 9 minutes left. I'm not going to worry about it. We've already taken quite a few of these. Even if it's... I want to wait till about... it hits 33%. And then I'll stop the image. And then we'll move the mount to the cave. So that'll be interesting. See an alien in the left camera? Exactly. It's going to be interesting to see what we get. We'll wait till it hits 30%. Now. Okay. Perfect. Alright. So now both cameras are now done. We're going to stop the guider. Alright, the guider has now been stopped. We're going to save these images. Perfect. Alright, so now that's all saved. And now we'll move to the Cave Nebula. Caldwell 9, so I don't know. Let's see. Okay, yeah, that is it. Okay, perfect. So now we're moving the mount, as you can see on the bottom left. Alright, now we have moved the mount. And we'll see where we are. Oh. There we go. I forgot. Gotta get the 20 for the gain. And see where we are in the sky. Alright, so now let's see where we are. File. Save. Plate solve. Shouldn't be too far from where we're supposed to be, because we didn't have to move too far. Alright, let's see. Alright, so now it should take about 40 or 50 seconds to find out where we are in the sky. All right, found it. Found it in 20 seconds. All right, let's see how far it moves. Not far at all. That's perfect. Perfect. We should be right there. So now we'll wait about 15 seconds, and we'll take another image, see where we are, and we'll be ready to go. Okay. Now we'll take a 13-second image, see where we are. Perfect. We're dead center. Oh, yeah. That's dead center. Fantastic. I mean, it's unbelievable. Yeah, you could start to see some of the detail, and this is even a 13-second image. That's insane. Wow, that's crazy. All right, so 13-second image. We are set. We are ready to go. Let's get the guider up and ready. Let's see if we got any good guide stars. Not bad. That's a good guide star right there. Perfect, and now we'll start guiding. See how guiding is. Let's see, 0.86. Well, let's try that and see what happens with that. Okay, so now we're going to change the name on it. There we go. So it is called Caldwell 9, which is the Cave Nebula. I changed the exposure time on both of them. So now it is 8 minutes on the left and 10 minutes on the right. Guiding is not as perfect as the other one, but that's okay. Should still be able to get a 7 to 8 minute image on both of them. We'll see. We're halfway on the camera on the left, and we're just under halfway on the camera on the right. And I'll be right back. Back. Got less than 2 minutes left on the camera on the left. So we have about 45 seconds. And we should be ready and raring to go. And here we go. First image is coming up on the left in 3 seconds. Alright, let's take a look. Okay. Just gotta move it over to the left. Just gotta move it over. And move it down. Right there. There we go. So that's the Cave Nebula right there. So on the camera on the left you could see it, and then the camera on the right just finished, so we could take a look at that one. It's going to be right up at the top here. This is the cave right here. So it's not going to be prominent, only because you're taking a single exposure. But you're going to notice it though. You can see it right here. It like goes up and then around, and it goes through these two stars right here. So this right here is the Cave Nebula, and what happens is there is a whole bunch of nebula all throughout here. With it being a 10-minute exposure, this looks pretty good. I'm pretty ecstatic about that. Actually, it looks pretty good. This turned out really well for the camera on the left. There we go. That's much better. That gives you more detail. And again, which is just amazing that is just one 10-minute or 8-minute exposure. It's just, it blows my mind. And detail's starting to show up on the camera on the right, too. So you're going to start to see it a little bit. Alright, so the image is done. So it's the next 8-minute image. go. Perfect. Yes, Chris, the Cave Nebula, which is Caldwell 9. Both cameras are doing really good and getting detail, which is nice. This is what I want. This is what I need. So we're going to take 3 more images on the left, and then we're going to move it over to NGC 7822, and then we will call it a night. Alright, the camera on the left, right is done. Oh, that looks awesome. So the camera on the right does... The stars are not moving at 10 minutes. So we're looking great. So we gotta just keep taking images. Next one is done on the camera on the left. Alright, so we'll take one more after this, and then we'll make our way over to NGC 7822. Although, we could probably just get a few more of these and probably call it a night. It is 12:30. What I'll probably do is we'll get this for about another 26 minutes and then we'll call it a night. And what we'll do is we'll leave 7822 for the next stream. I did promise the cave one on this one. Was we promised the cave, and we darn near got this one, which is great. So we'll get, we're taking 10-minute exposures. We're at 77%. We'll take 2 more on the right. Apparently Zane doesn't know how to comment on YouTube, apparently. He texts me to tell me he's watching live. Zane is one of my coworkers, and he doesn't know how to get on. I will show him. You have to make sure you create an account onto YouTube. You create a username, and then you'll be able to comment. We'll get you on. Don't worry. We'll get you on, so this way you'll be able to watch and comment at the same time. But Zane, what we're getting here is the Cave Nebula, which is Caldwell 9. It is a hydrogen emission nebula, where it's very prominent. And we're going to get about 2 more images on the right, and we'll get 3 more on the left. And then we will call it a night. So we will be done at 1 a.m. Eastern Time. Now, the next time it's clear, we are going to do what's called a mosaic. So we changed it up on the fly. So instead of getting 4 objects tonight, we are only going to be getting 3. But that's okay. Because these objects, you can't do short exposures. You have to do long. Because long exposures with these ones, you have to pull out as much detail as you possibly can. So the next stream, what we're going to be doing is we're going to be getting Cedarblad 214 and NGC 7822. I think that's what the object names are. Let me just double check. Yes, I was correct. And those objects sit just west of where the Cave Nebula is, and just west of where we were last night when we got the bubble. So we'll be getting all of that, which is super awesome. And the way that Cedarblad 214 and NGC 7822 sit is they sit just far enough away from apart from each other where I have to actually take one image of one object and then take an image of another object and then stitch the image together. And it's supposed to be semi-clear Sunday night. But if it's clear, it's only going to be clear till about midnight. So if we're going to be getting anything tomorrow night, it's only going to be for about an hour to an hour and a half. So it will not be a lot of time if we're going to get anything. So if there is an object out there that you guys want me to... I mean, I'll be more than happy to do a request night. If there's anything that you guys want me to get, please let me know. I mean, as I said, it only takes me just a few minutes to find the object in the sky, get it centered, and go. So, it doesn't take me long at all to do. So that's easy. And we could even get the smallest objects. Like I said, we can get very small objects, like we got the Blinking Planetary Nebula earlier this evening. And that was small, but we got it. There we go. Because there's a lot of objects in this area where I could definitely get something. Alright, so we'll take one more image on the right after this. Right now we're at about 41%. We're at 65% on the camera on the left. On the camera on the right, I mean. So 84%. And we will finish right at 1 a.m. Alright, so this image on the right should be just about done. The image on the left is finished. So we're down to our final image of the night. The stars look phenomenal. Guiding is absolutely perfect. So here we go. So the next image is going to be done on the right. We'll have to see if the stars move. Perfect. And it got darker, which is what I want. And we're on to our final image of the night. Should make it a little bit darker here. There we go. Now you can be able to see it a little bit better in detail on the camera on the left. Camera on the right definitely has a lot of detail, so you'll definitely see it a lot better. Yes, unfortunately I know that there's a dust mote right in that wrong spot. Right here, there's a dust mote. Stupid dust mote. Let me see the camera on the right. So we're about halfway through the last image of the night. So about 3 minutes left on the camera on the left. And 5 minutes on the right, and we will be done. So, with that being said, I'm going to start closing up shop. So by the time the last image hits, we'll be out of here. So, I want to thank everyone for coming on tonight. It has been a phenomenal night like always. We started off with the blinking planetary nebula. We moved our way back to the elephant trunk, got some more images with that. And we're finishing off with the cave, which is more images for our processing parties, which we will get to this upcoming week. I promise we will get to them. It's a matter of time. But the next clear night, again, we will get NGC 7822 and Cedarblad 214. Now, before that, like I said, I'd like to get objects from you guys. So please, please, please send me suggestions. I don't care what it is. I don't care where we have to go. But let me know. So I'd like to get that done. So the last image is finished on the left. Took quite a bit of images, which is nice. And we're just finishing, just waiting on that camera on the right. And you're very welcome, Joanne. It was definitely a great night. And we're just waiting for this last image to finish, which we're at 85%. So in about another minute and a half, and we will be done. So we're going to let this last song play out. And when the image is done, we're closing up shop. So, with that being said, thank you, Joanne. Astro Live channel. Stacy, thank you so much. James. Ron from Earth Radio. Amol. I know Eli, you were on. Zane, I'm pretty sure you're still watching. Even though you're not commenting, you're still here. James Dugan from Down Under. Genghis Khan. Thank you guys. I really do appreciate it. So you guys have a wonderful night. And I will talk to you guys later this evening. Have a good one, guys. Bye.